Now let's talk about the vectors in the motion. Okay, so here just to clarify some terminology. So here we have the displacement at distance. Roughly speaking, they are referring to the same thing. But in fact, when we use the displacement, we mean the vector description, and the distance is the corresponding scalar. So for one-dimensional vector, one-dimensional, for example, if you move from point 1 to point 2, okay? So, and suppose this is, like say, positive x direction. If I ask you, what is the distance of the motion? Say here, the length of this is 5 meters. So if I ask you the distance, you only need to tell me this 5 meters. You don't have to tell anything about the direction. Okay. But if I ask you the displacement of the motion, you have to tell me this is 5 meters to the positive x direction. Okay. Because 5 meters can also be described a motion from 2 to 1. In that case, this motion is 5 meters to the negative x direction. So both of them will 5 meters, but that's two different directions, right? So vector, the displacement, means both the direction and the magnitude. Similarly, velocity and speed, in our daily life, we use the two terms in the same way. But in fact, speed is a scalar, and velocity is the vector. Okay, so for example, if it takes 1 second from point 1 to point 2, so the speed will be 5 meters divided by 1 second. So it's 5 meters per second. Okay, speed. And the velocity will be 5 meters per second to the positive x direction. Okay. For one-dimensional, of course, it's quite trivial because it's either to the positive direction or negative direction. But for two-dimensional, that means here. In two-dimension, if I ask you the scalar, like speed or distance, you only need to calculate this one, magnitude. Okay, that's enough. But if I ask you the vector, the velocity or the displacement, you have to calculate both the magnitude and the orientation angle. Okay, so that makes quite different. Here, we know that distance is the corresponding scalar of displacement, and speed is the corresponding scalar of the velocity. So I would like to ask you, is distance is always the same as the magnitude of the displacement?
No.
Not necessary, okay? And the reason is that for one dimension, this is true. Okay, so you can see for one dimension, the vector can be either to this direction or this direction. Okay, from this point to this point. But their magnitude is of 5 meters. It's a distance. But you can see for two-dimensional motion, that may not be true. From 1 to 2, okay, the motion goes from this path or this path 1, okay. This is path 1, this is path 2. Okay. So this distance is different with this distance, right? But for the displacement, you have the same displacement. Displacement is always defined as with the final point and the initial point. Okay. So even if you use the motion from here, the distance is calculated from the actual path. The displacement is always calculated from the straight line connection of the 2 points. Okay. So in that case, the distance is not the same as the magnitude of the displacement. Okay. So that's a quite important difference between the scalar and vector in 2 or 3 dimensions. Okay, any question here? Now let's look at speed and velocity. Okay, again, the speed may not be the same as the magnitude of the velocity. Okay, because speed, by definition, it has to be calculated from the distance. It's distance divided by the time. And velocity is a vector. It has to be calculated from the displacement. Divided by the time. So if you look at the motion from here to here along this path. So to calculate speed, you have to use this length, the distance. If you calculate velocity, you have to use this length. Okay, the displacement. So of course, for this motion you can see, your average speed will be larger than your average velocity. Okay, so speed and velocity are quite different. For the same motion, the average speed may be larger than the average velocity. Okay, please remember that. But for the instantaneous speed and instantaneous velocity, they always have the same magnitude. Okay? Here we're talking about average speed and average velocity. They can have different magnitudes. But instantaneous speed and instantaneous velocity, they will have the same magnitude. The reason is that instantaneous, let's check how can we get the instantaneous quantity. We have shrink the 2 points along the path to 1 point, right? This is our initial point, this is our final point. So the instantaneous point is about 1 point. So if you consider some 2 adjacent points, like this is 2, this is 1 here, because they are the 2 adjacent points. So there is essentially only one way to connect them. Okay. So there is no difference between the straight line and the curved line. So both of them, okay, so the dx over dt anyway is just derivative here, there. So it makes no difference. Okay. Any question here? So there are some discussion about the scalar and vector. Okay. Now let's introduce the unit vector so we can express the those vectors in a more compact way. A unit vector is a vector that has a magnitude of 1 and points in a particular direction. Okay. Any unit vector, so for example, if a vector with magnitude of 1 and points to the x direction, we call it x direction unit vector. And then we have y direction unit vector and z direction unit vector. And we call them as I cap, j cap, and k cap. Okay. cap means, in this notation, we put a cap to mean the unit vector. And ijk specifies the three directions, x, y, z. In some textbooks, they use x cap, y cap, and z cap to denote the unit vector along x, y direction. And here, there is one thing. We have to specify which one we mean by x direction, y direction, and z direction. Okay. Because the question is that if you say this is x direction, if the y direction, we make it to into the blackboard. Okay. So for three-dimensional notation, it comes like this: x direction or y direction into the blackboard. So x direction to this direction, y direction to this direction. And then for z direction, please note that there is an issue about direction. Z, you can put it either upward or downward, right? So here we have to make the rule so everybody use the same kind of Cartesian coordinates. So our rule is that if we put x to this direction, y to this direction, z has to be upward. If you put x to this direction, y to this direction, z has to be downward. Okay, how can we determine the direction? We use the right-hand rule. The right-hand rule has to be made like this. Use your only right hand. Please note that we have many different right-hand rules in physics, in the study of science, but we only use right hand. Please never use your left hand. Okay, physicists doesn't have left hand. And similarly, in fact, if you for engineering, you know that all the tools they follow the right-hand rule, the screw. Okay, if you want to type it, always to the counterclockwise direction like this. That's also for the right-hand rule. Okay, so here this right-hand rule is to make it like that. First, pointing to the fingers of your right hand to the direction of x. Okay, so like if our direction of x is to that direction, so I made it to this direction. But of course, you can see that I still have some freedom to place my right hand. I can do this, or this, or this, right? All of them, I pointing my finger to the x direction. Now, let me check my y direction. I will arrange my hand in a way, so if I bend my finger, it will go to the y direction. Okay. So if my y direction is to this direction, I have to put my hand like this. So I can bend my y finger to y. If my y direction, say, to this direction, I have to put my hand like this. So I can bend my finger to y direction. Okay. So this is to fix your position of your hand in terms of x direction and y direction. So now if this is my x, this is my y, I have to put my right hand like this. Any question here? And then the direction of thumb will be the direction of z. Now you have only one way to place your thumb, right? So this is the direction of z. So if this is x, this is y, this is z. Any question here? Now let's check another situation. Okay, I said if this is x, this is y, then my z direction has to be downward. Let's see if I can do this with my right hand. Okay, if this is x, this is y. I place my hand to x direction, and then I have to be able to bring my finger to the y direction. This way. So I have to place it like this, right? So I can bring my finger from x to y. Now you can myself, it's downward. Okay. So for that, you can do any kind of x, y, z direction, but you can keep them from x, y, z or x, y, z like this. Okay.